Hey guys, this is Coach Brian coming to you with part 2 of our 1.3b notes. So in part 1, we talked about using the square root method, and in part 2, we're going to be discussing completing the square. And so I want to give you some background information to start with from Algebra 2. I went back and looked at the old notes from even when I taught this, 2 years ago, because I want it to be something that's got some continuity to it. You've already learned this, and so I want to use the language that you used around the first time. And so the first thing we need to talk about is the 3 forms that we can use of the quadratic equation. So 3 forms of quadratic. All right, 3 forms of the quadratic equation or quadratic formulas, functions that we can use. The first one we're going to use is just our standard form, standard. And this is probably how you'll see them the majority of the time. It is y equals ax squared plus bx plus c. That's our standard form. Like I said, it's pretty common. It's useful. It gives us some good information. Our c value is our y-intercept, so that's helpful to know. Second, we have the factored form. And this is kind of like an in-between type form where you're kind of like mid-solve, but it shows you your x-intercepts, which is super helpful, especially for when you're graphing. So x plus f times x plus g. And the f and the g would be your x-intercepts. And then lastly, the one that we're going to use today quite a bit is our vertex form. And you can guess probably from the name that it's useful because it contains the vertex. And if you remember from anything in the past, the vertex is usually signified by the point hk. And so if you plotted the h and then the k as your x and your y, and you mark that point, that is going to be the turning point of your quadratic. It could be a maximum, it could be a minimum. And this form of the equation is written like this. Y equals a times x minus h squared plus k. And so your h and your k will give you the center, not the center, the vertex of your parabola. And one thing I want to point out just from the start here is that it's x minus h. So sometimes I'll put a positive right there to show that the x is positive. It's really tiny, so I wrote it really badly. But it's subtracting a positive h. So sometimes that sign will change, and that can be confusing to students. So maybe I made it more confusing, I don't know. So our goal today is to take a standard form of the equation and find a constant to add to both sides so that we can create a perfect square trinomial. Okay, so a perfect square trinomial. And just to give you an example of that, we're going to expand this guy up here to show you what a perfect square trinomial looks like. So whenever you have a binomial like this, it's got 2 pieces to it, or two items in it, and it's squared. One mistake that a lot of people will make is they want to distribute the square, and so they'll say, okay, the answer is x squared plus 25, and that is absolutely wrong. Okay, we don't want to do that. So if you're listening to this video, you'll hear me say that, but if you just have it paused and you're clicking through, you will miss that and you'll be mad that I made you erase. So what we want to do is double distribution, and there's a couple different methods. They all kind of do the same thing. When I was growing up, it was the FOIL method. First, outer, inner, last. When I was teaching, it was the box method. And they both kind of do the same thing. So I'll illustrate it using the box method. So what you do is I'm multiplying x minus 5. And since it's squared, I'm multiplying it by itself. So x minus 5 again. And then you just multiply diagonally. So x times x is x squared. Negative 5x, negative 5x, negative times negative is positive. And so these two with x's, you combine like terms, go together, and I would end up with, sorry, I'm just running out of room, so I would end up with x squared minus 10x plus 25. And that would be the expanded version of this binomial, and it is a perfect square trinomial. Now, another way that we illustrated this in Algebra 2 was we used what's called algebra tiles. Okay, we used algebra tiles. And if you still want to use these, they're on a website that you guys have access to called Polypad. Okay, and you can still use those. Your goal, if you're trying to make something a perfect square, is to use the tiles and make a square. Like a perfect square will actually make a square out of the tiles. But there's also another way you can find, our goal is to find a constant. We have that right here, find a constant. The way that you can do that, a method that you can use to do that, is using your B value, okay, your B value. Your B value is the number that is in front of the x, not the x squared, but the x. So first step, I'll try to give you a step-by-step here. Step 1 is isolate x squared plus x. Whatever that looks like, you want to get the x term and the x squared term isolated on one side of the equal sign. Next thing, you want to take this number. I'm gonna rewrite this real quick. Let's say you want to isolate ax squared plus bx. Because the next thing you want to do is you want to take your b value. Okay, you want to take your b value and you want to half it. Box it. Square it. Sorry, I can't write. Square it. Add it. Undo it. And so as I go through these, I'll try to use that language quite a bit. But if you look at the picture right here, see how you have the b value? The first thing they do is they half it right here, and they half it right here. And then what they mean by box it is you're going to put an even amount of them on the side and an even amount underneath. And what that creates is this like missing zone right here. And like we said, when you're using the tiles, you want to create a perfect square. So you want to find how many actually fit in that space. And so that's where we get to the point where we square it, b over 2 squared, and then add it and undo it is going to happen while we're solving. So I think the best way to move forward now is going to be, let's work some examples. This b over 2 squared, that's going to be really key going forward. So that's ultimately what I want you to remember is b over 2 squared. So what we're doing here is we are trying to complete the square of this equation. Now, if your Algebra 2 teacher was me, Coach Brian, or Miss Sala, Miss Brown, Miss Brady, I know that for sure we were calling this the gross C value, okay? And we were saying that you want to move it. And so we're going to be doing the same thing. We're going to be taking that 16. Right now it's negative 16. And we're going to add it over to the other side. And that leaves this vacancy right here, okay? And the rule, when you're completing the square, you don't want to change the value of the overall function. So whatever number goes in that blank, I need to actually add it to both sides, and that's where the add it step comes in. So where does the number that goes in this blank come from? It comes from b over 2 squared. And so right now, b is 6. 6 over 2 is 3. 3 squared is 9. So I'm going to put a 9 here and a 9 here. So what that did for me, I'm going to erase this a little bit. I'm going to rewrite it, don't worry. B over 2 squared. What that did is that on the left side here, that made a perfect square trinomial. And the reason I like a perfect square trinomial is because I can easily factor it. I can factor it. And so I'm going to factor and get x minus 3 squared. And then on my other side, I've got 16 plus 9, which is 25. And the last step of our list over here is undo it. So I'm going to actually move the 25 back to the other side. And so my vertex form is going to be x minus 3 squared minus 25 equals 0. And now, why is vertex form useful? Because it's got our h and our k, and we're looking for our vertex, which is hk. So our h is positive 3. And you might be looking up there and saying, why? It's x minus 3. Well, it goes back to what I said at the beginning. The original sign right here is negative. So a good way to think about it is I'm saying x minus positive 3. So the turning point of this graph is at 3, negative 25. Our final step is to solve for x. We want to actually know what x equals. So we're going to start with that vertex form. And we are going to add 25 to both sides. Remember, we're solving for x, so we want to isolate it. That leaves us with x minus 3 squared equals 25. And then it's actually just the square root method that we did in part 1 of the video. We want to find the square root of both sides. And so square root squared cancels. And the square root of 25 is positive or negative 5. And again, positive 5 is an answer, negative 5 is an answer, so you want to have a positive solution and a negative path. So I'm going to do x minus 3 equals positive 5, and I'm going to do x minus 3 equals negative 5. And I'm going to solve both of those by adding 3 to both sides. And so my final answers for x are 8 and negative 2. 8 and negative 2 are my two possible x answers. All right. The next example is just like that one. It says complete the square to write it in vertex form and then solve for the values of x. So we just used completing the square. We're going to do the exact same process again. We are going to start by getting rid of the gross c value, okay? We want to move that to the other side. So we're going to subtract 48 from both sides. And in its place, we're going to leave a blank. Okay, we're going to leave a blank there because we want to create a perfect square trinomial. And because we don't want to change the value, we need to put that blank on both sides because whatever we add to one side, we want to add to the other. If we don't do that, we change the value of the entire thing. Now, the next step is I want to take this b value. Sorry, I left an x off right there. I want to take this b value of 14. I want to half it, and I want to square it. So that would give me 7 squared, which would give me 49. So I'm going to add 49 to both sides. Now on the left side, I have a perfect square trinomial now. Perfect square trinomial, which I can factor, and I can factor it to x minus 7 squared. And on the right side, I have negative 48, or sorry, x plus 7 squared. Sorry about that. On the right side, I've got negative 48 plus 49. That's just going to cancel out at 1. Okay, it's just going to cancel out at 1 for me. So the last step is undo it. So that means I actually want to take this 1 and move it back to the other side so that I'm set equal to 0. And that gives me my vertex form, which I'm just going to rewrite right here. X plus 7 squared minus 1 equals 0. And so why do I like vertex form? Because it's got my h and my k. Now, the vertex is negative 7, negative 1. And that might seem confusing. You're saying in your head right now, out loud, maybe, it's positive 7. How did you get positive 7 and turn it into a negative 7? It goes back to the original. Look at the original. All right, every time I come back here, I'm going to make a new mark around it. Look at the original. It's x minus h. So for this to have become addition, it must be x minus negative 7, which means my h value is not positive 7, it's negative 7. Subtracting a negative becomes addition. And then the negative 1 is just a negative 1. To solve for x, we're going to use our vertex form. And we're going to isolate x. So we're going to start by adding 1 to both sides. After we do that, we're going to use the square root method and find the square root of both sides. Square root squared cancels. And the square root of 1 could actually be positive or negative 1. We're going to split into a positive path and a negative path. On the positive side, I'm going to set it equal to positive 1. On the negative side, I'm going to set it equal to negative 1. And I'm going to solve both by subtracting 7. So on this left side, x equals negative 6. On the right side, x equals negative 8. So those are my two answers. And I'm probably about to get caught by the lunch bell, but I'm going to keep going. We have 2 more examples and then a question with a written response that I want you to answer. So, example 2 here is very similar to what we've been doing. The only difference is now there's a coefficient in front of the a. If you look, there wasn't one in front of the A here, it was just a 1, and there wasn't any number here, it was just a 1. So now we're dealing with a coefficient, which isn't going to change much. We're just going to factor it out when we get to the factoring, or right before the factoring step. So first thing we want to locate is our gross C value. And I'm going to just keep calling it that because I know that's what your Algebra 2 teachers called it. And I want to move it to the other side. So I'm going to subtract it from both sides. That will give me 3x squared minus 12x. I'm going to leave my blank here, equals negative 36. And I'm also going to add a blank over here because I've got to add this number to both sides. The next thing I want to do is I want to take my b value, which is 12. I want to half it, and I want to square it. I want to half it, and I want to square it. Sorry, I got just a step ahead there, actually. Sorry about that. Bell threw me off. I want to next get rid of the 3 like I was talking about. I want to factor it out. So on this side, if I take out the 3, it's almost like dividing both things by 3. So I take out the 3, that leaves me inside x squared, and on this one, a negative 4x. Still got my blank over here. I've got my 3 out front. And so you might be wondering, like, how do I show that on the other side? How do I show that I did that on both sides? In front of your blank right here, you're just going to put that 3. So again, I'll change the color. In this blank and this blank, you're going to put a number in there, and it's going to match on both sides. How do you find that number? You take your b value, you half it, and you square it. So it actually gives me 4. Gives me 4. Because half of 4 is 2, and 2 squared is 4. So at this final step, I need to simplify the two sides, and I need to get it into vertex form. So how do I do that? First, on the left side, I've got my perfect square trinomial. I need to factor it. So that will give me 3 times x minus 2 squared equals, and on the right side, I'm going to distribute this, so that gives me 12. Still got a negative 36. Negative 36 plus 12 equals negative 24. For vertex form, the last thing I want to do is undo my number over here by adding it back to both sides. And so I've got a vertex form that is 3 times x minus 2 squared plus 24 equals 0. And so when I look at this and I get my k value, when I get my k value and my h value, I have a vertex located at 2. And why is it positive? Because I'm subtracting a positive 2. And at 24. 2 and 24 would be my vertex. Now, to solve for x's, I'm going to take my vertex form. I'm going to set it equal to 0. And I'm going to solve for x. I'm going to subtract 24. I'm going to divide by 3. And then I think I'm about to run into a big error that I shouldn't have run into. There's the tardy bell, by the way. So what I'm about to do is I've got to find the square root of both sides, and that's going to give me an imaginary number. So what I need to do, this is not right, but I'm just changing it for the sake of the problem. I'm going to change, okay, if you're not actually listening to the video, this is going to confuse you a bunch. I'm going to undo that because that was not what I wanted. I'm going to erase this, and I'm going to make it negative. The reason I want to make it negative is because that will make this negative, and the reason I want to make that negative is because it will change these two signs. And I'll be dealing now with a positive number. So, was that correct? I don't think so, but just let's go with it for the sake of not dealing with imaginary numbers. I'm going to find the square root of both sides. Now, square root squared cancels. Now, on this right side, I don't have like a clean square root. And if you remember from algebra how to simplify it, it looks something like this. You can cross one out, kick one out. And so you end up with a positive negative 2 square root of 2. I'm going to relocate that so I can write it a little bigger. Hopefully you remember the cross one out, kick one out. So I've got x minus 2 equals positive or negative 2 square root of 2. And the last step, because I have a positive route and a negative route, is to work both sides. So I'm going to do x minus 2 equals positive 2 square root of 2. Gotta let my pen catch up, sorry. And on this side, I'm going to do x minus 2 equals negative 2 square root of 2. Now, these are unlike terms. Don't know why that just happened. Man, it just erased all my work. Man, okay. All my work disappeared, so I'm gonna start where I'm at because I am absolutely not re-recording this. I was at this step. This erased everything. That's okay. If you've been following, you count right back up. So I'm going to do x minus 2 equals positive 2 square root of 2. On this side, I'm going to do x minus 2 equals negative 2 square root of 2. And the thing is I'm going to add 2 to both sides, but these are mixed numbers. These are not like terms. So I'm going to have x equals 2 square root of 2 plus 2. And on this side, I'm going to add 2. But again, they are not like terms. So I'm going to have x equals negative 2 square root of 2 plus 2. And those would be my final two solutions. All right. I know this is getting long, but got to work all these examples. Want you to see a variety of problems. I'm going to work this one a little bit faster, though, because I want to be done, and I know you want to be done. So gross C value. Gross C value. Move it to the other side. That's step 1. Leave a blank in its place. Factor out the 4. Got to do it on both sides. Figure out what number goes in the blank. Use that B value 2 over 2 squared. 1 squared is 1, so I'm going to add 1 to both sides. Next step, I'm going to keep simplifying. On the right side, over here, I'm going to distribute, and I'm going to combine like terms. So that gives me 24. On the left side, I'm going to factor, and it will be x minus 1 squared. Lastly, I'm going to subtract 24 from both sides, and that gives me my vertex form. My vertex is hk, so I've got my h value and my k value. So this has a vertex of 1 and negative 24. And then to solve for my x's, I'm going to take that vertex form and I'm going to solve for x. Should get 2 answers. Add 24. Add 24. Next step, I'm going to get rid of the 4 by dividing. (24) divided by 4 is 6. Next, I'm going to use square root method. Square root squared cancels, so I have x minus 1 equals plus or minus square root of 6. I've got a positive route. I've got a negative route. And I'm going to keep finishing this because I'm so close and we're about to have a drill. So x minus 1 equals positive square root of 6. X minus 1 equals negative square root of 6. And to solve, I'm going to add 1 to both sides. These are mixed numbers, so I'm going to have square root of 6 plus 1 and negative square root of 6 plus 1. The end. Sorry for the interruptions and the corrections along the way. I hope this helped, and I will see you in the next video.